class, the first thing you need to do is you need to go to aplusstudents.com. Once you're on the website, you select math as your subject. Okay. Your grade is grade 4. This is a lesson for grade 4. The name of the topic is decimals. We would be studying decimal numbers today. Okay. And the chapter number is, let me give you the chapter number 10 and lesson number 4. Chapter number 10 and lesson number 4. And we would be studying equivalent, EQUIVA, equivalent decimals. Okay. So the term equivalent means equal. Okay. Hi Baruch, welcome to the class. We will be looking at fraction decimal numbers and we will see if they are equal or not. Okay. So we go to go to grade 4, chapter number 10, decimals, and lesson number 4. Okay. So before doing that, let's see what are equivalent fractions. Okay. If this is an example we have, see, one of the boxes has been divided into 10 segments and the other box has been divided into smaller 100 segments. Okay. So what we need to see over here is, are these two fractions equal? Okay. Are they equal? Okay. So the first one we say is 1, 2, 3, and 4. That means 4 out of 10. Okay. And this was 40. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 10 plus 10 plus 10 plus 10. That is 40 out of 100. Right? So we want to see if they are equal. Are they equal? Yes or no, right? We are considering decimals also. So what we can do is, if we have a 0 in the numerator and 0 in the denominator, we can cancel the 0 and we can say this is also 4 out of 10, right? So as a fraction, they both are equal, right? If they're equal as a fraction, they will be equal as a decimal also, right? But let's see how we can convert this number into a decimal. See, in the numerator, we have 4 written, right? And it's divided by 10. That means it is 4.0. The decimal was here. From here, we move the decimal to this position. One place for the decimal. So we write 0.4. And this is also 4, right? Or 40. So we may, how many zeros were there? There were 2 zeros. So we can say 0.40, right? And they both are equal. Why? A 0, no, may it would be 0.04 means 4 out of 100. This is 40 out of 100, right? So 0.4, right? So if you write 0.4 or you write 0.40, they are exactly the same thing written. Why? Because a 0 in decimals after a number does not have a significance. What we can do is we can still write a 0 over here just to show that these two numbers are equal, right? So 0.4, yes, thank you, May, is equal to 0.40. Okay. So yes, they are equal, right? That means they are equivalent decimals. And these two values were equivalent fractions, right? So what we are trying to study today is we would be looking at equivalent decimals, okay? decimal numbers that are equal. Thank you, Rowan. Thank you, everybody. Okay. So the first question that we have is, it says, are these two decimal numbers equivalent? Let's see. For question number one, okay, the given information is this, and they are asking us if these two numbers are equivalent. Are they equivalent? For question number one. So how can we check whether they are equivalent or not? See, what we do is we try to write the numbers together. This was and the next number was this. What we need to see is the decimal comes right under the decimal. And I just told you something, that 0 at the end does not make any difference. So are they the same numbers? Yes, they are. They are exactly the same numbers. So we can say they are let's move on to the next question. We can say they are equivalent decimals, or we can simply say they are equivalent numbers, or we can say they are equivalent decimal numbers. Okay. Let's go to the next question. What they are saying is, are these numbers, decimal numbers, equivalent or not? Okay, I'll just copy it. I'll wait for you to answer also. Okay. And they are asking if they are equivalent or not. Can anyone help me out? Question number 2. So are these numbers equivalent? The second question, question number 2, are these numbers equivalent? So what we do is we copy the first number, 0.3400, and we copy the second number, that is 0. We need to remember the decimal comes under the decimal, right? 340. And we know that 0 at the end does not have any significance, right? It can be removed. Yes, they are. Very good. They are equivalent decimal numbers. Okay, thank you. Moving on to the next question. The next question says, okay, in the next question, what they have done is they want us to give an equivalent. Okay. So which decimal is an equivalent number to this given number? So what we need to do is we need to give an equivalent number. Question number 3. So our original question was 0.070, right? And we know that the 0 at the end, this 0 at the end can be added or can be removed, right? So if we say we want to give another equivalent decimal number, so can we say 0.0700? right? We add 10, or from the original we remove 10. Can we say if we remove 10, can we say 0.07? So if this was the original question given to us, then these two numbers would still be, no, 0.07, because the first position of 0, we have to keep it as it is, right? A 0 between decimal and the number has a value. We cannot remove that. But the 0 at the end of the number, we can remove that. Okay? Okay. So it cannot be 0.7, Adibai and Semi. We can remove the 0 at the end, or we can add a 0 at the end. Over here, we added an additional 0. And in this case, we remove the 0. Right? Do we agree? And over here, we added one more 0. So these, okay, no problem. No problem. As long as you can understand, that is very good for us. So if we have to give an equivalent decimal number, we will try to change the zeros. Either we add 10 at the end, or if we can, we will remove the 0. Okay? Okay. For the next question, it says, okay, are these two numbers equivalent fractions or equivalent decimals? So they have given us two numbers and they're asking us would these two numbers would be equivalent decimals? Let's see. For question number 4. Okay. They're asking us is 0.66 equal to, is 0.66 equal to 0.67? Are these two numbers equal? So whenever we have a different set of numbers, they would never be equal. Yes, see, we can always write this as Semi 0.6600, right? Or even we can add 3 zeros. But if we write the other number 0.67000, so what we can see over here is that they both are not same, because one of the numbers has 6 and the other number has 7th on the 100th position, right? So what we say is, or simply we can see this is 66 and this is 67, right? And we know that 66 and 67 cannot be equal in fractions. So we have a sign for not equal. Okay, not equal. We can write in words, or what we can do is we make an equal sign and we slash it. We cancel the. So if I write not equal, the sign in the middle would read as 0.66 is not equal to 0.67. Okay, Virok, stop that. Let's focus. Okay, thank you. Okay. For the next question, they are saying which decimal number is an equivalent number to this given number. Okay, so let's see what we can do over here. If this number is given to us, okay, equivalent to this given number. Question number 5. So if the original number that was given to us was the 3 zeros, if I say 0.1 with 3 zeros, we just need to give one number which decimal number is equivalent, right? So what we can do is either we can add 1 0 to it, right? We increase it by 1 0, they still are equivalent. Or what we can do is we reduce it by 1 decimal. Okay, so if we reduce it by 1 decimal, then this becomes 0.1. This was 3 zeros, we simply write 2 zeros. They still are equal. Or if we want to do something else, we reduce again by 1 0. Or we can say that if we again 0.1, so that means all of these given numbers, this number would be equal to this number, and this number is equal to this, and eventually the last is also equal. So this would be okay. Yes, thank you. No, Akin, uh, Semi, what you are doing is you're bringing 0.0. There is no zero before after the decimal, right? So yeah. So out of all these one, two, see, out of all these options, first, second, third, and fourth, they all will be equivalent, right? Nate, you need to remove the zero after the decimal, because in the question over here, we do not have a zero after the decimal, right? We have a decimal and we have a 1. We can add zeros after the number, okay? And why? All these options are correct. They all are equivalent decimals, okay? Do I need to repeat this? Do we need to do this question again? Or is it understood? Nate and Semi, what you are doing is you are adding a zero before the number. The zeros can be added after the number in the decimal cases. You cannot write 0.01. It has to go 0.10. We can add as many zeros as we want at the end, but that would not make any difference, right? Okay, thank you so much. Let's look at the next one. Let's say which decimal is equivalent to, okay, 0. Okay. 0.000 in question number 6, right? So if we say our original number was given as this, 0.000, right? That means, thank you. That means there were 3 zeros. It still equals to 0, right? It's still a 0. So either we remove 1 decimal or we increase 1 decimal. It would still stay as a 0. It would still stay as a 0. Or you can write it as 0.0. What we do is we prefer not doing too much work, right? Sorry. We prefer keeping it simple. Preferable answer would be this. Otherwise, all the options are correct, right? Yes. Yes, Semi. It does not make any difference. May, do you understand? Because we want to minimize our work. So we say 0.0 is also, if we say 0.0 is an equivalent fraction to 0.30, right? That's the easiest, yeah? Or 0.00 is also equivalent. So all these 4 options given to us are equivalent, and what's Semi typed with like infinite number of zeros, it will be the same. But writing infinite number of zeros would take a lot of time. So we just try to give the basic answer. Okay, thank you. Let's see what we have in the next question. The next question which we have is, it says which decimal is equivalent to, okay. So let's go to question number 7. And the question number 7 says, which decimal is equivalent to this? So if our question was 0.15 with double zeros, right? If this was the question given to us, we just simply need to find an equivalent fraction. What we can say is 0.150, or the easiest would be 0.15. So we can say either of these are the same. We can increase the zeros. No, Nate. No, Nate. The decimal comes below the decimal, right? So this would mean either we remove the number of zeros or we increase the number of zeros. It would still stay the same, right? So we can say that 0.15 is an equivalent fraction to 0.1500, or we can say 0.150 is also equal to 0.1500, right? Or we can write 3 zeros. It would still be equal. If you write 0.15 with 3 zeros, it would still be the same, right? So we don't have to worry about it. Preferable is, I would recommend that you give your answer in this form. Okay, the minimal work 0.15. If they are more than 1 0, 2 zeros, just remove the zeros. Okay, so let's look at the next option we have. The next question we have, okay, would have multiple numbers in it. Okay, so let's see. In the next question, what they are saying is, are these two numbers equivalent decimals? That is the question they're asking us. Are they equivalent? And how do we confirm any given pair of number is equivalent? We write them down. So can we say, sorry, the first number goes with the second number. The decimal comes right below the decimal. So are these numbers exactly the same? The digits? Is this digit exactly the same as this digit? And the third position also, right? The only difference is the zero at the end, right? So we can say that 0.6540 is equal to 0.654. Okay, that means, thank you, Rowan. That means these two numbers are equivalent. Let's look at the next question. So the next question we have is, they're saying, which decimal would be equivalent to this? We need to find an equivalent decimal for this. And that is question number 9. So we know that we can add zeros. We can add zeros, we can remove zeros, right? So if the original was given as 0.700, right? This was the question given to us. What we can do is either we take out a zero, right? Or we add a zero to it. This could be 0.730. So the easiest example would be the first option, right? Because it saves us a lot of time. We can say 0.7 is equivalent to 0.700. Agreed? Do we agree on this? But these all four options would be equal, right? So these kind of questions are known as open-ended questions. That means any two students would not have, they might have different answers, but still their answers would be correct, right? Depending on how many zeros would they put at the end. Okay. So for open-ended questions, it's a open choice. Thank you, May. So the next question, let's see. Are 0.90 and 0.0 equivalent? Let's see. Are these two numbers equivalent decimals? Let's see what the numbers are given to us. If these are the numbers given to us in question number 10, the first number was 0.90, right? And the second number was 0. The decimal comes right above the decimal and 0. So we can add an additional 0. It does not make a difference to us, right? So what? Yes, thank you. We need to look at these two numbers and see if they're equal. So we can say if 0 is not equal to 9, then 0.90 is not equal to 0.0. Yes, thank you. Thank you, Adiboy. Thank you, May. Thank you, Rowan. And yes, they are not equal. I explained you the sign, right? An equal sign slashed out. You make a slash on it. It means not equal, unequal. Okay. Moving ahead to the next question. If they are saying which decimal is equivalent to this given, can you people answer for the next question? Question number 11. Can you give an answer? Because this is still an open-ended, right? And I told you, right, an open-ended can have, every student can have a different answer to it. So if this is question number 11, we can say, can you give me an equivalent decimal? If this was 0.860, this was the given question. Can I have an answer? The easiest answer would be 0.86. You remove the decimal, or you can say 0.8600. So that means 0.86 is equal to 0.860, right? Or 0.8600 is also equals to 0.860, right? Yes. Nate, you wrote 80. It should be 86, yes. Yeah. So all of these, any option that you consider would be equivalent, but we always have a preferable. I would recommend this because this is saving our time. We are not writing too many zeros, right? So we just simply remove the 0 at the end. In the 0.860, easiest to remove a 0. So we simply remove the 0 and we write 0.86. But still, they all are correct. Okay. Moving on to the next question. The next question says, okay, they're asking us if these two numbers are equivalent decimals or not. Let's see. They look very different, but let's see. Let's still see if they are or they are not. Are these given two numbers equivalent decimals? For question number 12. So the first number is 0.2. So we can write 0.2. And the second number was 0.200. So are these two numbers equivalent decimals? We look at the position of this. Zeros don't affect the number. Yes. They're just simply asking them about these two numbers. So what we can say over here is 0.2 is an equivalent number to 0.200, right? Yes, they are equivalent decimals, right? Or we simply write equal sign. Thank you. Moving ahead to the next question. No, Nate, you cannot put a 5. You're generating random numbers. That means if you're generating a random number, that would be different, right? We just need to look at the numbers that is given in the question, okay? Okay, for the next question, they're saying, are these two numbers equivalent fractions? Okay, let's see. Equivalent decimals, sorry. We are looking at decimals, apologies. Equivalent decimals, okay? So are these two numbers equivalent decimals? Question number 13. We can say 0.923 and the next number was 0.923 and 0, right? So all we need to do is we need to look at their positions. 9 under the 9, 2 under the 2, and 3 is under the 3. For us, 0 will not make any difference, right? We can add a 0, we can remove a 0 at the end, not in between the numbers. So what we can say is, yes, 0.923 is an equivalent decimal to 0.9230. Yes. Okay, one more question, Rowan, then we'll do the test, okay? From the next slide, we'll do the test. One question, then the test. Okay, very easy one. Just the last question, and then we are going to the test. Okay. Okay, the next question says, which decimal is equivalent to 0.5? Let me just realign this. Sorry. If I just put it over here, and let's see. Can you give me a decimal number that is equivalent to 0.5? Yes, May, they are equal. Rowan, just this last question, then we are going to the test. Okay. So the question is saying 0.5. Can anyone give me an equivalent decimal to 0.5? 0.5 does not have a 0 at the end. So what we can simply do is, yes, we simply add a 0 at the back end. So what we can say is 0.5 is the equivalent decimal to 0.50, right? Or we can put, yes, thank you, Rowan. Or we can put 2 zeros, 3 zeros, 100 zeros, right? But putting so many zeros would waste our time. So 0.50 is more than enough for us, okay? Okay, let's move on to the test now. Let's try some questions from the test. Okay, let me just copy those questions. Okay. Just a minute, please. So the first question that we have in the test says, let me just give a heading for the test so that others would know. We are doing a test right now. The first question of the test says, are these numbers equivalent decimals? 0.00 and 0.9. Are these numbers equivalent decimals? Yes or no? Yes, Roman. Thank you. How do we know they are equal? Because when we write 0 point, right? You're saying yes. No, you're saying no. Okay, thank you. 0.90. Wrote, I read yes, then I was like, oh, okay. Then this was 0.0. All we need to do is we need to look at the first decimal place. Are these two numbers same? They are not equal. Not same, right? So we say that 0.90 is not equal to 0.0. No, they are not. Thank you. Thank you, Rowan. Thank you, Buruk. Thank you, May. They are not equivalent fractions, okay? For the second question they are saying is, which decimal is equivalent to the given number? Okay, we have two options, option A and option B. Let's see if these were the two options given to us. And I'll just resize it so that it's readable for us. Okay. They're saying which decimal is equivalent to this given number. Can I have the answer? See, yes, thank you, Rowan. In question number 2, what we can do is the 0 at the end of the number, the number that is ending with multiple zeros, right? Yes. Why not option 1? Because we need 1 5. This is 5 1. Agreed? So we can say 0.1500. We simply remove the number of decimals. This would be same, right? That means option number 2. Thank you, Adibai and Rowan and Scarlett. So we say the second option is the correct answer. Okay, let's look at the next one. And we need to see if these two decimals numbers are equivalent or not, right? So for the next question that is given to us is this, and it's a simple yes or no. And they're saying just find whether these numbers are equivalent or not. For question number 3, they're asking us if this number is equivalent to this. Yes or no? Yes. Thank you, Rowan. We needed 15. We did not need a 51. So what is the easiest way to see if they are same? Yes. Thank you, Nate. The easiest way to see is we write down the first number and we write down the second number. Ignoring the zeros at the end, if we say that the numbers are same, right? If these two numbers are same, then yes, they are equivalent fractions. We can only ignore the zeros at the end, not in middle of the numbers. Okay, let's see. I'll just make a question just to explain what I just said, right? Let's make a question for ourselves. And I would make a new question over here. Okay, this is not the test. I'm just making this for ourselves. If I say 0.203 and 0.0203, are these two numbers equivalent fractions? What I just wrote on the screen, yes or no? The first option is no. The second option is yes. Let's see. What can we say about these two numbers? In the question number 4, are these two numbers equivalent decimals? Yes, thank you, Rowan. Why are they not equivalent? Because if we write 0.2, 0.2 0.03, and we carry the next number, that is 0.0203, right? So we can see that the numbers are not on the exact place, right? So they are, no, they are not equivalent decimals, okay? So I just did an additional question over here. We just changed this. Let's move back. Yes, thank you. The numbers differ. So the question we had was in the test. Now we are looking at the test. The question in the test states that, okay, let's say this would be our question number 5. Which decimal is equivalent to 0.5? If this is our question number 5. Out of these two options, which would be 0.5? Simply, we can say this has 8. 8 cannot be equal to 0.5, right? So if this was 0.5, an equivalent can be 0.50, where these two numbers have to be same. Yes, option number 1. Thank you. Just by looking at the both options, we can also find the answer. Okay. So the next question we have is, which decimal is equivalent to 0.4690? Okay, it's a bigger number. It's a larger number given to us. These are the two given options. And they're simply asking which decimal number is equivalent to the given number. Question number 6. Option A or option B? Yes, thank you. Why? Why, Rowan? Because these numbers are given in the question. We cannot find these numbers where? In option number 1. Yes? 1 is only 4. It does not have a 6 or 9. Right? So that means, yes, Rowan, thank you. Okay. So if the question was given as 0.4690, so it could be 0.469, but it cannot be 0.4. This is not possible. Okay. This is possible. The numbers are different. Okay. So we are also looking at the reasoning, right? We can always look at the answers and we can say that they are either equivalent or they are not equivalent. But most important for us is the logic behind that we should know the reason. Why is it happening? Okay. For the next question, question number 7, they're saying, are these two numbers equivalent decimals? I'll just resize it so that this is readable. Okay. For question number 7, they're asking us, are these numbers equal? It's okay. No problem. No problem. See, when you give the answer, I also understand that you have the reasoning. Okay. It's sure. What about question number 7? What can we say about this? Okay, you're saying it's equivalent. Yes. Let's see why. If the first number is 0.3400 and the second number is 0.340. So what we can see over here is that the numerical values we had, the numbers we had, were at exactly the same position and they were exactly the same, right? So that means, yes, they are equivalent decimals, right? And we remember that A decimal comes right exactly under a decimal, right? Okay, Rowan, do we agree? Okay, there are a few more questions left. Okay, thank you. Very easy questions. Okay, give the remaining a try and try to complete the quiz. Okay, try to complete the test. If there is any problem, you can always go through the lesson. Okay, best of luck. Have a nice day. Thank you so much. Take care.